My name is Matt Thompson, and this is going to be the Getting the Most Out of Amazon EC2 session. I'm actually the global head of EC2 Spot, which we actually will be talking about in this session. So you can see if I put a little extra effort into that. Let's go ahead. We got a bunch of content to get through, so we're just going to start right away. We're actually really just going to do three things in this session. First, we're going to give you a general overview of EC2 instances and how far it's come. Secondly, we're going to talk a little bit about how to optimize basically your EC2 capacity usage and pricing. And then third, we're going to actually just give you some real world workload examples in which to practice that optimization. So some light architecture. So let's jump in right now. Little history. About 13 years ago, Amazon EC2 launched in 2006. We offered only one instance size and type. It was the M1 instance. It came with just one vCPU and 1.7 gigabytes of system memory. The most important thing we did there, though, with EC2 at the time was actually allow you to just pay for what you used. And what that means is that you could scale up and scale down as you needed without actually incurring extra cost along the way. And that's what's become our on-demand model. Fast forward 13 years or 14 years to 2020, and we actually have the broadest and deepest platform of choice. What's happened there is we have almost 300 different instances by the end of 2020, 275 plus today. And what that means for you as a customer is we can support virtually any workload or business need that you have. We just believe that that kind of breadth and depth supports better performance for specific workloads that you may have today. So we've come a long way in kind of those 13 years. We're going to talk a bit about instances in this next 30 minutes. So I want to spend just a little bit of time talking about the taxonomy of an instance so you can familiarize yourself. So every instance family, just like that M1 I mentioned at the very outset, has a certain basic use type. And so in this case, the instance family, if you will, is the M, and that's a general purpose compute type. The instance generation actually follows that. I talked about the M1. In this case, what we see is an M5 instance. So that just means it's the fifth generation of the M series. We also have this little thing that's called additional capabilities. In this case, that little D, for example, means that this instance just has instance storage that's physically connected to the host server. We have a bunch of different things there like an N, et cetera, but in this case, it's a D. Importantly, that extra large, that t-shirt size. And in this case, an extra large has 4 vCPUs or virtual CPUs associated with it. And each size or t-shirt size that you go up has a doubling of those CPUs. So for example, 2XL will have 8 vCPUs and a 4XL will have 16 vCPUs. So family, generation, most importantly, and then size. So that's just in case you get lost along the way. Let's go really quickly through our instance types. So we have general purpose instances, and these are great for stuff like web applications, small databases. These are our kind of general purpose types. Then we have memory optimized instance types, and those are great for workloads that process large amounts of data in memory, like NoSQL databases, MongoDB, for example. And then we also have compute optimized instance types, and these are high performance processors, more or less, that are great for batch processing workloads, ad serving, media transcoding, all of that. So I want to stop there on instance types. We have more, but I want to talk about those because those are underpinned by kind of a broad choice of processors that we have today. And we've always had Intel underlying our instance types. We moved into some AMD processor types underlying our instances. And then finally, we started to build our own with Graviton. And with AWS at reInvent last year, we actually announced our Graviton2 processor. In 2018 at reInvent, we announced our Graviton1 processor, which was introduced as the A1 instance type. But in 2019 at reInvent, we announced actually a vast performance increase with the Graviton2. And that's up to 7x faster than actually our Graviton1 processor was. And so what does that mean kind of in terms of what you're going to do with these? And so what that means for us today is that these Graviton instance 2 instance processors will actually go into general purpose, compute optimized, and memory optimized instance types in the future. So what you'll be seeing for us soon in 2020 is us releasing basically the M, C, and R series, but the 6th generation, so not the 5th anymore, but with Graviton underpinning it. So you see like the M6G and the C6G, et cetera. Overall, I'm not going to go too deep into these industry benchmarks, but you can kind of see the orange is basically this M6G processor, or M6G instance type, I should say. The blue is actually the M5. So we're just comparing our last generation instance type to a newer generation instance type. And I'm really just going to generally call out the fact that these instances, these M6G instances, perform about 44% faster. And so what that means for you as a customer is you get actually better cost to performance ratio. Just to kind of complete our instance type journey, talk about storage instances. So these are basically designed for a lot of I/O operations, right, on local storage. And then large data sets, for example, are great for these. We also have, very popular today, our accelerated computing instances. These are backed usually by graphic processor units, so GPUs, right? And these are great for AI ML workloads. So when you think about, say, floating point calculations in finance workloads or high performance computing workloads like computational fluid dynamics, and very popularly AI ML workloads like deep learning, our GPUs are actually custom built for those workloads. And then last, something we did also just announce at reInvent is our Inf1 processor. And this is actually very specifically tailored toward inference or ML prediction. And this is the only thing you really need to know about this instance type is that you get 5 times lower cost per inference than any other Amazon EC2 GPU. So these are very specifically built for prediction and inference. I won't spend a lot of time on this slide, but I think it's important to know that everything we do is actually built, backed by our Nitro system, which is very proprietary. It just, for us, what we did in 2013 and released our first instance types on this platform in 2017 is we rethought the entire virtualization architecture. And what that means for you, the customer, basically is just you get quicker innovation from AWS. You certainly get better security with the Nitro security chip, and then obviously better performance on a server by server basis because we've offloaded a lot of the management to other servers so you can use more fully functional server. And of course, if we talk about instance types, we have to talk about EBS volume, so storage, right? And so block storage has always been available to attach to EC2 instances, super performant. Like customers use SAP on top of our block storage, our EBS volumes, very reliable with 5 nines. And then there's 2, just like instance types, there are 2 kind of types of EBS that are good for tons of different types of workloads. So basically we have SSD EBS volumes and we have HDD. SSD is great for transactional databases or enterprise applications, whereas HDD is very good for like log processing and big data. And then I would be remiss if I didn't mention the security with EBS. And I'm just going to talk about this through another reInvent announcement last time, which is default encryption for your EBS volumes. So if you're looking for a very secure storage method, EBS is very secure these days because we just announced default encryption where you can bring either an AWS provided key or a key that you create yourself. So we just spent a ton of time on how I'm thinking about how AWS, by focusing kind of on customer workloads, we've really evolved our technological portfolio in EC2 to accommodate any kind of workload or business scenario. But we also don't like it when customers actually are not very optimized in terms of how they use their EC2. And so we want to provide a bunch of different pricing models, capacity kind of features, if you will, like optimization capacity features, and then guidance to kind of help you along the way. And so what we're going to do with the kind of the remainder of this presentation is take all that huge breadth and depth of our technological portfolio and try to help you figure out how to optimize it for like the next few years. So let's go into pricing models first. So we have 4 different kind of pricing models overall, right? The ways to purchase EC2. We talked about on-demand at the outset. On-demand was our initial way to purchase EC2 instances. And this is the kind of pay-as-you-go model. And this is great for workloads where you're not really sure how much you're going to need or how much you're going to utilize. And so on-demand will let you spin up and spin down with no extra risk. Then we actually introduced reserved instances. Reserved instances basically made it very possible to achieve high discounts in on-demand in exchange for, say, a 1 to 3 year commitment to purchasing that instance. These are great for steady state workloads. So these are workloads that you know and are going to pin to a certain usage all the time. No reason not to actually purchase a reserved instance. But I want to spend a little more time on the other two, savings plans and spot instances. Savings plans we just announced at reInvent, which is actually, I think, a tweak and a good tweak in terms of improving reserved instances. And then we'll talk a little bit about spot instances, which is our spare capacity for EC2. And spot is actually up to 90% off of on-demand. So let's spend a little more time on the latter two. So savings plans. Let's just move right through this slide. The most important thing to note about savings plans is they're just more flexible than reserved instances. And so we're going to see that here in the next instance. So let's delve a little deeper into savings plans. At AWS, we actually offer two types of savings plans. One is the compute savings plan, and the other is the EC2 instance savings plan. Let's start with the one on the right first, the EC2 instance savings plan. The cool thing about an EC2 instance savings plan is that it offers you a 72% discount off of on-demand. So let's say, for example, you have an M5 XL in on-demand. If you're going to use that all the time, you should move that to an EC2 instance savings plan. There is an hourly commit in terms of spend that we ask you to commit to, if you will, to get this kind of savings plan. But here is the difference from this between the EC2 instance savings plan and a reserved instance of the same type. The coolest thing here is you can actually move sizes within a family. So let's say you started a savings plan, an EC2 instance savings plan. You're getting 72% off that M5 XL. And along the way, you decided that your workload just sung. It just worked a little bit better with an M5 4XL. There's no cost, no hassle to try to change that M5 XL to an M5 4XL along the way. And that's something you couldn't do with reserved instances. So that is an EC2 instance savings plan. The one other note is that actually you can also change operating systems. So if you're working on Windows, you can move to Linux, vice versa. Let's spend a little more time on compute savings plans because they're even more flexible. Not quite the same amount of discount. Now, this is a 66% discount off of on-demand. But one of the things that's really nice about there are two things, actually, I should say, that are really nice about the compute savings plan. One is you can change instance families. So let's say you're using that same M5 XL and you decide you need a compute optimized instance type and you want to move to a C5. You can do that. You can move to an R5. Etc. So that savings plan will actually apply to any of those instance families, not just in terms of the size within an instance family, like an EC2 instance savings plan. The other cool thing about a compute savings plan is that you can change regions. So let's say there's some political event and you need to move from the EU, so Ireland in the EU, into the London data center. You can totally do that with a compute savings plan. So you can actually move your regions with a compute savings plan as well. And this was something that wasn't achievable before. And then finally, actually, your spend on this kind of compute savings plan also applies to a serverless architecture like Fargate. So we have our Fargate kind of serverless container service. If you want to spend your savings plan there, you can as well. So it's kind of some of the benefits of savings plans. Now let's spend a little bit of time talking about Spot. Spot's a lot like on-demand in the sense that you don't have to make any commitment to AWS. You just spin it up, you spin it down, and you pay for basically what you use. The one difference in Spot is that this is our spare capacity. So imagine that AWS, what you're really doing, by the way, here, imagine that you're just leveraging the AWS scale. And the scale comes from stuff like Black Friday. So when you think about how much on-demand AWS has to make sure we have for something like a Black Friday event where shoppers are shopping all the time, but the rest of the year, there's not quite that much demand, right? But we have to make sure we have that capacity. That's the chief promise of elasticity. So what do we do with the rest of that capacity the rest of the year? We sell it as Spot. And so the one contract we make, or the caveat we have with Spot is, if for some reason we need that instance type back, we'll give you a 2-minute warning, and then we'll reclaim that instance for you. But that's also why you get somewhere between 70 and 90% of on-demand with Spot. So if you're able to deal with those types of potential interruptions, Spot's actually a really good purchase model for you. And we'll go deeper into Spot right here. So there's some real strategies to using Spot. And I'm only really going to focus mostly on the one on the left, which is instance flexibility. The way we think you should be using Spot is to construct what we would call a fleet of potential instance types. So if we go back to our favorite M5 XL in this example, what we would say is, hey, if you're willing to use an M5 XL on Spot, maybe you should also use an M5 2XL and maybe a C5 XL and a C5 2XL and so on. And what we ask you to do is construct a large fleet of resources there. So that means your workload needs to be not primed for just one resource type or one instance type, but many instance types. And in this case, that ends up allowing for you, if you use Spot, is quick replacement of any lost resources. So instance flexibility is key to Spot. Time flexible and region flexible are also important. If you're a CI/CD workload, for example, which is very popular with Spot, it might just complete a few minutes later than normal. And that's the time flexibility because you might have lost a couple instances and rebalanced in the middle. And then region flexibility, if you're willing to move to different regions, sometimes there's more Spot capacity in different regions. And so these three types of flexibility are really key to using Spot. So let's talk a little bit about interruptions. The one question I usually get is, I don't know if my workload can handle the interruptions inherent in Spot. The truth is, there are two answers to that. First is, man, interruptions do not happen as often as you think. So in the last 3 months, only 5% of all Spot instances were interrupted. But that's only a part of an answer and probably only 20% of the way. What we like to say is that you really should prepare for interruptions. It's just better architecture and better fault tolerance on from your workloads. And so we've actually developed a bunch of strategies for that. So for example, checkpointing. Let's just take the top of these. If you have a CI/CD workload and you're basically running that and it gets delayed, if you will, and a Spot instance is removed, basically on the 2-minute warning, what is best practice is to checkpoint where your workload was actually at, so kind of a save, if you will. And then that way, when you get a new Spot instance move in, it just restarts in the same place and you're good to go. So checkpointing is an important piece of this. We've also developed tools for some of our more popular types of workloads. When you talk about ECS and EKS, so container systems, or so like a classic ECS Docker-based container system, or EKS with the Kubernetes scheduler, we actually have developed interruption handlers for both those container types. And what they'll do is actually terminate a node prematurely, drain it, and then basically spin up another node and let the job keep going. So we've actually prepared you for some of these interruptions along the way. So that's basically our purchase models, and hopefully you've learned a little bit about savings plans and Spot, as well as kind of knowing on-demand and reserved instances. Let's talk about not just how to optimize your purchase models, but how do you optimize your capacity? So how are you not running at basically, let's call it 30% optimum? And the first thing to note is we really believe that you should actually combine these purchase options to deal with your capacity. So if we look at this, the bottom or the orange bar set represents basically your reserved instance or savings plan. You know this is always on. Basically, put that underneath your data. Number 2 is on demand. Then make up with a little on demand. And then the third is Spot. So maybe a better way to think about this workload is something like a big data workload. The master nodes are on the bottom. Those are always on. You got to keep them going. So put them on something like an RI or a savings plan. And then you might try to meet your SLA, get that big data job done. And you might use on demand for that, right? Because it's got to be done and it can't be interrupted. But if you want to exceed your SLA or really burst, you can add Spot to that. And that's a great way to think about combining all of the different purchase options. So what are the major kind of mechanisms we've built to help you scale well? And this is auto scaling. So EC2 auto scaling or auto scaling groups is a great way to dynamically scale up and down. This will make sure that you don't leave a bunch of instances running when they're not being utilized and incurring cost, right? That's one way to think about it. It also means that when you have increased traffic, it'll actually push up or bump up your supply of instance power that you might need. So when we think about that, basically, I'm not going to go into the lowest cost option today, which is the middle of this. This is basically if you really want to cost optimize, and especially with Spot involved, you can actually choose an option called lowest cost, and we'll basically go try to seek basically to find you the cheapest possible capacity for your workload. But we are going to spend a little time on capacity optimized and prioritized list here in a second. So let's talk just really quickly about auto scaling. So auto scaling has been around for a little bit of time. And the interesting thing about auto scaling is we've really learned from our customers what they wanted to do. So the smart customers were really ahead of this optimization game from the start. And before, we used to have, again, what we call auto scaling groups. And before, smart optimizing customers built custom logic. And so what you can see in this diagram here is what they would have to do is actually build 3 different auto scaling groups that work together. So on the top, the orange, obviously they had an M4 large with Spot, and then an M5 large with Spot as well. And then they had to mix in basically a C4X large on demand. And so they had to kind of basically create 3 different auto scaling groups, some hefty configuration and coding. And so there just wasn't a clean way to leverage all of the different purchase options together. So we kind of listened to the customer on that and really changed the way auto scaling groups work so that we could combine all of what I just said, these purchase options, RIs, on demand, and Spot all in a single auto scaling group. So it just wasn't like the domain of just a heavy coder, for example. And the main thing this did for our customers, besides simplifying the ability to optimize, right, was it made sure that the customer could fulfill their base capacity with on-demand instances and then additional with any Spot instances. Or they could mix a specified percentage mix of on-demand and Spot so they could maximize, or I should say minimize, their cost for a workload. And now we've kind of gotten even more advanced. So one thing we heard from our customers is that they really wanted to tune this, right? So obviously we had optimized for purchasing, but we hadn't necessarily optimized for basically really making that workload work in conjunction with purchasing. And so we added weights. And so what weights do, so these are the prioritized instances I mentioned. What weights do is they allow our users to privilege certain instance types. So in this case, if we look at the diagram, we actually see that M5 4XL on demand has a weight of 16. And I'll let you sit there and look at that. And the other ones are basically 4 and 8, right? So roughly half of this, what our user is saying, or our customer is saying, we really think the M4 4XL is great for our workload. So we want to make sure it's always half of this auto scaling group as it comes up. So this is a great way to really fine tune your workloads. And then we talked a little bit about auto scaling with capacity optimized allocation strategy. This is actually very tuned to people who are power users of Spot, of which there are quite a few. And one of the things we heard from Spot is, hey, I can deal with interruptions all day. That is great. I don't mind them, but I just don't like a ton of them. Can I get something where basically you can help me maximize or minimize interruptions, I should say, or maximize my uptime on my workload? And basically we came up with the capacity optimized allocation strategy. And all this really does is you can see at the top, you basically put in, again, a fleet of instance types, in this case, an R5 large, an M4 large, and an M5 large, and then select the capacity optimized allocation strategy. We'll just go in and basically find the deepest pools of Spot resources for you that we believe, based on machine learning, will minimize your interruptions. So that's the capacity optimized allocation strategy, and it's kind of a best practice for Spot. I should mention that basically all of these, both auto scaling and Spot, is basically available in a bunch of different managed services. So it's not like you actually have to stick together a bunch of different AWS services. So services like ECS and EKS, which I mentioned already, as well as AWS Batch for high performance computing workloads, already kind of have Spot and auto scaling groups natively infused into what they do today. So it's a great place to use them. And then of course, partners, ISVs out there like Qubel on the big data side, or CloudBees, which runs Jenkins, the Jenkins open source CI/CD platform. They've actually obviously integrated Spot and ASG in to make it easier to spin up and down compute using their tooling. So the last one's guidance. So we talked about pricing capacity, and we've really started to get heavier into guidance around which instance types you should select. And what we announced at reInvent in 2019 was AWS Compute Optimizer. And the AWS Compute Optimizer uses machine learning models trained on millions of workloads. So you can imagine we have millions of workloads and millions of instances working all the time at AWS, and we get a good insight into what optimization looks like. So we've trained this on millions of workloads, looking at resource utilization, configuration, performance data, and all of that, we come up with instance recommendations. Are you right-sized or not in terms of what you're using? Should you be using a smaller or larger one? And so in this case, Compute Optimizer, on average today, we see that reduced costs on instances by about 25%. So it's pretty impressive given the basically 6 or so months that it's been live. The only thing to note on Compute Optimizer is it's free. So no reason not to use it. And it's actually available in the AWS Management Console for all customers. So if you have one takeaway today, the easiest one without any architectural change or pricing change, having to call your AM or anything like that, is actually AWS Compute Optimizer. So with the remaining time, I just want to go through some really light architecture diagrams on workloads. So let's talk about analytics and big data first. This is kind of a simplified reference architecture for a big data workload. And I'm just going to call your attention to just a few things here that are important. So you'll notice, I've said before, the master node has to be on RI, a reserved instance, or a savings plan, or OD, something that will not go away, right? So that's where you see your master node in the upper left here. But then you have your instance fleet. If I'm going to draw your attention to the top of that, which is the core nodes, right? Again, we find that those are better on demand or RI. We have a couple customers that want to run those on Spot, but it's not a best practice. I don't recommend it necessarily. But most importantly here is where you get the maximum optimization or kind of savings, if you will, is really in that lower left task fleet. So ultimately, big data workloads often are made of tons of task nodes, right? We find it to be a best practice to put those on Spot. Many big data workloads actually can lose a node, rebalance, restart, and keep going without any problem at all. And so one of the things that we go out and talk to our customers about in terms of best practice of architecture is to put task nodes on Spot. So it's a good example of kind of a more mature architecture for big data. So let's move into CI/CD or DevOps. So I'll actually kind of mentally include dev test workloads in here, but this is more of a perfect CI/CD reference architecture. This one happens to be using Jenkins, obviously a very popular CI/CD pipeline tool. In this case, just kind of, again, calling your attention to some of the diagram, you can see everything's behind an ALB or an application load balancer. And in the VPC, which is that nice box to the right, basically what you see is the Jenkins plugin launching Spot instances as agents. So behind the application load balancer, you actually see the Jenkins master, again, not on Spot, but on OD or RI, so that's there, but all of the agents on Spot. So basically what will happen here, same idea, can rebalance, can checkpoint, and what we see is since these are non-production workloads, they can finish a little bit further along, but they're also a great place for cost savings if you're looking to save money inside of your org or optimize something, or optimize that workload, right, that CI/CD workload. So Spot's a great choice in this workload. And then the last one where we actually see combining different purchase options to be very important are web applications. And obviously everybody has internal, external web applications out there. It looks a little like the CI/CD workload, just a bit from a load balancing side. In this case, it's not an ALB, but an ELB, an elastic load balancer in front of a dynamic set of resources, right? And so the ELB in this case actually automatically routes incoming web traffic across just a dynamic number of changing instances. So you can imagine web traffic spiking, et cetera. And so what this will actually do is optimize the auto scaling group depending on how much application demand there is. And again, I just want to call your attention to a couple things. If you notice first, this is a containerized infrastructure. So this is working on ECS, serving up a website. But the other thing you note is we actually kind of have mixed and matched on demand and Spot. So Spot on the left-hand side and then on demand on the right-hand side. And so one of the best practices with ECS on web applications or any web application really is no more than 30% on Spot is usually a best practice for this. We have customers, again, that use more, but that's what we find to be a best practice. So quick takeaways from this presentation. I'm not going to go over all of them. Basically, if you didn't get the fact that we have 300-ish instance types and sizes, basically good for every workload out there, from general compute to GPUs and AI ML. That's an important thing to note here. We can actually handle pretty much any workload with our breadth and depth. Number two is we really want you to automate and find kind of like your cost and capacity optimization, because we understand the breadth and depth can be a little complex sometimes. We don't like it when you're running at 30% capacity. We want you to be fully utilized and use the right pricing model for your workload. And then the last one just here is, if what I said, you want to dive a little deeper into anything, you want to get a little more technical on our Nitro, whatever it may be, go and visit the learning library at aws.training. And you can learn way more about kind of some of this cost and capacity optimization with EC2 that I just went through. And with that, I just want to thank you for your attention. Take care.